In this video, we're going to review what is voltage potential, why it's important, and how it's measured. The peak-to-peak voltage of an alternating current, such as the 150 kHz hydropath signal, is the amount of voltage from the top of the sine wave peak to the bottom of the sine wave peak. For example, if the peak positive voltage is plus 10 volts and the peak negative voltage is negative 10 volts, the peak-to-peak voltage is 20 volts. Prior to a detailed explanation of how to measure the peak-to-peak voltage, let's take a step back and review how the hydropath signal is induced into a piping system. Hydropath technology works using a similar concept to a transformer. Through the primary coil, an AC current induces a field in the core, which then induces a current into the secondary coil. Now imagine a secondary coil with only one turn. Straighten that coil and hollow it out, turning it into a pipe. The hydropath signal is then induced into the pipe and the water in the pipe the same way a standard transformer induces a signal into a secondary coil. If the pipe is non-conductive, PVC for example, the water itself will carry the signal both up and downstream. As the signal travels further away from the source, it will begin to dissipate. Using transformer technology is what makes HydroFLOW unique and the only patented technology capable of inducing a signal into a plumbing system without altering the existing piping in any way. To measure peak-to-peak voltage, energize the HydroFLOW device and run the oscilloscope probe through the ferrites. A video explaining how to properly capture the hydropath signal can be found on our website. As mentioned earlier, the hydropath signal gradually dissipates as it travels further away from the unit. To ensure the signal is treating the entire system, we need to measure its strength at various points throughout. While peak-to-peak voltage measures the hydropath signal strength at the point of induction, voltage potential is the transducer's ability to propagate the signal throughout the system, or in other words, the amount of potential energy between 2 points in a circuit. To measure voltage potential on a metal pipe, touch one side of the ferrite ring with the probe tip while the other side is touched by the alligator clip. If we want to measure the voltage potential at a point further away from the unit, we need to connect a 16-gauge wire to the alligator clip of the scope and clamp it to the pipe on one side of the ferrite ring. Then touch the probe's tip to a point downstream across the ferrite ring, which will document the voltage potential at that point. Note that the voltage potential will be lower than the peak-to-peak voltage at the unit due to the distance. Ideally, you should see a few volts throughout the system. If the voltage potential measurement is under a volt, you should consider installing an additional HydroFLOW unit. Thanks for watching.